All right, let's talk about one of the most important, but kind of invisible pieces of tech that makes the whole internet work. We're going to pull back the curtain on the unsung hero that keeps your favorite apps and websites from crashing.
I mean, have you ever really stopped to think about it? You've got billions of people online, all clicking and streaming and shopping, yet somehow the giants like Google or Netflix are just always there. How do they do that? It's not magic, but it is some seriously clever engineering.
Okay, so before we get to the solution, you've got to understand the problem. It's a wall that every single popular website eventually slams into. This is the perfect way to think about it. Picture a supermarket, right? It's Saturday afternoon, and there's only one single checkout counter open. The line would snake all the way to the back of the store. People would be getting angry, frustrated. Some might just drop their basket and leave.
And that is exactly what happens when a website runs on just one server. You know, a viral video, a big holiday sale. Suddenly, a flood of visitors shows up, and that one server gets completely overwhelmed. It slows to a crawl, or worse, it just crashes. That single server becomes a massive bottleneck.
So what do you do? Well, you could try something called vertical scaling. This is like firing your regular cashier and hiring a superhero cashier who can scan things at lightning speed. You're just making your one server way more powerful, more memory, faster processor. But you can see the problems here, right? There's a hard limit to how powerful you can make one machine, and if that one super server goes down, your entire website is gone.
And that brings us to a much, much smarter and more resilient way to solve this. The horizontal solution.
So instead of one superhero cashier, what if you just opened up 10 regular checkout counters? That's horizontal scaling. You just add more and more servers to your team. They're all identical, and they can all do the same job. It's way more flexible.
But wait a second. This creates a whole new puzzle, doesn't it? You've got 10 checkout counters open. How do you make sure the lines stay even? You need someone at the front of the store, directing people, making sure one cashier isn't totally swamped while another is just standing there doing nothing.
And this is where our hero of the story finally comes in. We need something to act as an intelligent traffic cop for all those incoming requests.
And that traffic cop, it's called a load balancer. Its entire job is to sit right at the front door, look at every single person, every request coming in, and guide them to the best available server. It makes sure nobody gets overworked.
Now take a look at this. What's really cool is how it's all set up. Every user in the world comes to one single address, the load balancer. All of your actual servers are hidden behind it on a private network. This is great for security because they aren't exposed to the internet. The load balancer is the only thing that is. It's the single gateway that directs all the traffic from there.
This quote just nails it. It's the one front door for everything. To the rest of the world, your huge, complex system of servers just looks like one single, super reliable machine. But here's the thing. Spreading out the work is just half the job. The load balancer has another trick up its sleeve. You could call it a superpower. And it's all about handling failure. So the day-to-day logic is pretty straightforward. A request comes in, the load balancer quickly checks which servers are healthy and ready to work. It picks one, maybe using a simple method like round robin, where it just goes down the list one by one, and then it forwards the request. Simple as that.
This is the million-dollar question, isn't it? If you only had one server and it crashed, your site would be offline. Game over. But with this new setup, what happens now?
Okay, watch this. This is where the magic really happens. See the traffic flowing nice and evenly to all three servers. Everything's great. And oh, look, server 2 just crashed. Now watch the load balancer. It instantly detects that server 2 isn't responding anymore. And just like that, it stops sending any new traffic there. All new requests are now seamlessly sent to the other two healthy servers. The user has no idea anything even went wrong.
And that is called failover. It's the whole key to what we call high availability. It's just like the store manager seeing a cash register break and immediately telling everyone, please use these other lanes without missing a beat. The service just keeps on running.
So let's zoom out for a second. We've seen what it is, we've seen how it works, but why is this so incredibly important for the internet we use every day? Well, it really all comes down to two massive wins. First, you get insane scalability. Need to handle more users? Just add more servers to the group. Easy. And second, you get rock-solid reliability, because if one server fails, the whole system doesn't come crashing down. And that right there, that's the secret.
The next time you're scrolling through social media or binge watching a show or buying something during a massive online sale and it all just works, you can thank the quiet, invisible load balancer humming away in the background. Look, the bottom line is this. Without load balancers, you couldn't go from 100 users to 100 million users. It's the technology that makes the scale of the modern internet possible. It's truly one of the most fundamental building blocks out there. Which kind of leaves you wondering, doesn't it? We've uncovered one of the internet's hidden heroes today, but what else is out there? If the load balancer is the traffic cop, what other invisible jobs are being done 24/7 just to keep everything online and connected for all of us?